Hi guys, BuildZoid here, and today, well, I don't know. This is another pretty random video, but this might not even end up going public. But anyway, so I figured I'd sort of show you the procedure I used to make the original Probinator. So the thing that was developed using this i3-7350K here. The other thing that this has been doing is be a wall ornament, which is why there's blue tack all over it. And then also I was a CPU that I was checking capacitor clearances on for modding the CPU, well, for modding the back of a CPU with extra capacitors for Intel. But anyway, we're not going to take a look at that anymore. Off. There, I don't have enough space to work in here. No, so what I'm going to show you is basically how I figured out, which I, like, well, that's not really figured out. Like, here we're just going to, well, unfortunately, I've already done it. So, this is, I'm not going to be showing you, like, I'm not going to go through the full procedure. But basically, so for Intel CPUs, building the Probinator is a bit easier because there's an actual pinout. So you could do it without a motherboard. But that's actually kind of awkward. So the way I did it was, come back, actually, I need the i3 back. So I took the little i3 here, right? I took this i3 and I basically scratched through the substrate, and then I checked, like, hey, is this the vCore power plane? Is this the vCore power plane? While this was sitting in a, like, I'd be pressing it down into the socket, because that's the thing is, like, with Intel sockets, right? If you don't put any pressure on the chip, like, your measurements are going to be completely off. So I'd be measuring from the vCore VRM against the power planes of the CPU till I found something which was zero resistance. And it was like, okay, well, that's our vCore. So we're going to do the same thing here. We got my Keysight U1272A, and yeah. So we're just going to stab one of the vCore inductors. So on this motherboard, that's this one, this one, this one, this one, this one, this one. Not these two. Those are the SoC VRM. This motherboard right here is an X570 ITX from Gigabyte, but this is an engineering sample board which didn't have a chipset fan yet, which is pretty cool. I rescued this thing from the recycle bin at Gigabyte HQ when I was visiting. I also have a retail version, and I basically, like, I'm basically kind of just modding this board, so there's like a bunch of extra capacitors on the back, but like, the cool thing is now I have like a retail board to compare against, so I can do all the mods I feel like doing whenever I'm bored, and then I can just check against the retail board if they're actually any better. But anyway, because of that, I'm kind of thinking like, hey, I could... so this is a 2200G, so we can't really use this for Probinator purposes, because the issue with the... And even a 2400G is less than ideal, but the thing is just like... Delidding a soldered Ryzen chip just bloody sucks. So... The thing with the 2200G is that this is a quad core, no hyperthreading. It doesn't pull any power, so, you know, trying to measure transient response on this thing kind of sucks. But we can still figure out, like, hey, you know, what would be the best place to get a capacitor from, actually get a reading from. So on this chip, we have all of these capacitors on the top side, right? This is an AMD CPU. They don't put capacitors on the back of them. I'm not going to pull it out of the socket right now. Actually, well, no, I can. So the other idea I was toying with was trying to, like, tie a loop of wire. But yeah, like, there's no capacitors on the back. Ugh. There. So no capacitors on the back. But one idea I was toying with was just, like, throwing a loop of wire around one of the legs of the, well, one of the pins, and then measuring like that. But the issue is all of the actual vCore pins are on the... because you have all of your you have all of your bypass capacitors for the CPU, or like on the center of the socket. So all of the actual pins for vCore, where on Intel, you know, they start at all the way at the outer edge, and then they sort of work towards the die. On this chip, they actually start like on the inner edge. So they all start like on the inner edge of the socket, and then they work out to about here. So the last two, three pins on the outside, they're not. They're like for I/O or something, so they're not for power. Which means that idea doesn't work, because I was hoping to just like throw a loop on one of the outer pins, and then, yeah, but nah, it's not gonna work. So anyway, let's get one probe against an inductor, and then let's start checking resistances. So I want to just use one of the unoccupied pads over here, right? Actually, I'll zoom you in. Oh no. Yeah, should have thought that through. Oh, there we go. I was holding the probe in my mouth, so that's why it sounded weird. Oh, damn. I am slowly entangling the tripod here. Ugh. So it doesn't matter which way I put the probes. It's just like this one has a... Like, the tip on this one is really inaccurate, whereas this one's nice and sharp. So... Okay, well, this sucks. And... Well, I already know that this spot should be where we're... Whoa. Damn it. Okay, this isn't bloody working. Oh, there we go. So 0.05 ohms. Obviously, there's contact resistance in that, as well as the resistance of the probes themselves. But yeah, that pad right there, that's VCore. I wonder if the outer one is. Oh, can you actually... Oh, yeah. Actually, I can see better on the monitor, so... Oh, I'm trying not to... Okay, that's not... Because that's like 22 ohms. So that's a ground pad. So you might be wondering, like, these capacitors look a little bit weird. Right? If we really zoom in on them. You'll notice that instead of like normal capacitors, which, you know, just have two terminals, these have all these little legs. And so you have like multiple pads for one capacitor. These are called these are like super low inductance multi-layer ceramics. Very expensive by multi-layer ceramic capacitor standards. Like, they're not that expensive, but yeah, rather expensive. AMD likes them, and I've never seen actually anybody, like, I've never seen NVIDIA use them. I've never seen Intel use them, but AMD has them freaking everywhere. So yeah, they're kind of interesting in that way, but and the way they're designed is basically by having a lot of little connections, which I think the connections actually go like you have VCore ground, VCore ground. Well, it's not VCore ground, but you have positive, negative, like they're alternating, which terminals what. So yeah, that's done to essentially like reduce the inductance of them very, like the equivalent series inductance of these really, really low, which makes them better for, you know, filtering out high frequency switching noise, or at least that's what the point of doing all that is. Anyway, let's see if I can find another. Oh, I'm really screwing the camera focus right now with my hand. Ugh. Okay, this isn't working. Wait. Bleh. Get my hand through there. Yeah, I wish there was an easier way to access the VCore power plane on this board, but there really isn't. So, let's see. Hoping this pad... Right. There we go. Okay, yeah, that one's also VCore. So that one's actually really easy to access because it's really like outer edge. And then we could just measure against the other one. Now, the main issue here is, of course, that these tiny little pads are right next to, like... Yeah, that one's ground. So that one's 22. So if I stab ground now... So I'm just stabbing a screw hole on the motherboard. Right? And you can see we're getting... well, you can't see anything. Because of course you can't. Because I'm one man. There. So that's ground. Right? And then if we... Please focus... I'm gonna have to zoom out, aren't I? Oh, no. No, the camera... Man, this camera is so smart. Good job, camera. Unlike my kindergarten webcams, you can actually focus. Okay, wait. Where's the bloody other pad? Yeah. So this other pad's VCore. Yeah, so that one's VCore. Now, the pad right next to that is ground. Yeah, so that really sucks because if you put a little too much solder, you're gonna short VCore straight to ground. Which is, that's obviously not good, but that is a pretty convenient spot to actually take a measurement from. And I think, so this one is, that one probably is VCore as well. This one's probably VCore as well. These ones up here should be iGPU power. Actually, you can't see those. And we move this over. So these ones up here, probably all iGPU power. I think this dark patch right here, which you can't really, well, you can kind of see that this entire area is a bit darker. I'm pretty sure that's the actual VCore power plane. I mean, iGPU power plane in that area. So that's... Oh, I called these VCore, didn't I? These are all iGPU. Or probably all of these up here are iGPU because the way the power planes are designed is normally the iGPU comes in from the top and vCore comes in sort of from this edge, normally. Well, actually, with Ryzen, it probably doesn't matter too much because the pins are sort of in this area for vCore and iGPU. So, yeah, it's not like Intel where literally from the corner it comes in. So if your VRM goes all the way down here, you have to, like, the power has to go, like, from basically around the CPU a bit. But, anyway, yeah, so these are vCore, which is nice. I guess, like, the thing is, you can see that AMD, with their substrate here, we have a lot of really, like, we can see a lot of traces here and not a lot of, like, fills. So it really, I think it's going to be best to just try to go off of one of these capacitors instead of trying to scratch through the solder mask, because too much risk of actually, like, you know, cutting, like, PCIe lanes or something, and if you do that, well, I'm not repairing a CPU substrate, so that's not going to happen. So yeah, that's on a 2200G. My main concern with this is, of course, that these like don't pull any power, right? Like, this is a quad core with no hyperthreading, and then the 2400G is also a quad core with hyperthreading, which hyperthreading tends to add about like 30%-ish more power consumption to 40% depending on the workload. And there are some workloads that don't scale with hyperthreading at all, and those won't pick up any power consumption. Yeah, the thing is, I can't really... Like, ideally, I'd use a 3900X for this kind of thing, because that's like the, you know, that's not quite as expensive as, well, no. Ideally, you'd use a 3950X, but I can't afford a 3950X just to start, like, scratching, you know, just to attach wires to it. But, yeah. This, like, a 2400G is, like, pretty cheap at this point, so... Especially like secondhand or something, you can get them really cheap. So, yeah, I'm thinking I'll probably just use a 2400G. And the main issue is, like, I guess... I'm actually not sure how a 2400G would differ to a 3900X. Like, the other issue is, like, it's also completely different architectures, because a 2400G is, like, based off of first gen Ryzen in terms of and like the actual core is based off of first gen Ryzen, whereas which actually second gen Ryzen is still first gen core basically. It just clocks higher. So yeah, it's kind of, yeah, not sure. I mean, you can always, like, the thing is, you can always just stuff like stupid voltages into the CPU if it's not getting, like, if it's not pulling enough power, but there's a limit to how much you can do that, right? Because a quad core, like a 1700 will top out sort of slightly below the 200 watt mark. A 2400G will top out at like half that, right? And a 3900X or a 3950X, well, I tested a engineering sample 16 core in the past, and those chips, you could quite easily get them up to 300 watts. Now, they were completely uncoolable at that point, but you could do it. so it's just like, yeah, you know, testing the integrity of the, like, testing the capabilities of the VRM with a load that's like 1/6? Or, yeah, somewhere around 1/6 or 1/5 of what the actual, like, because 250 watts on a 3900X isn't actually that hard to cool, right? Like, it's like 300 watts, that's a big problem, but 250, 200, pretty easy. But getting a 2400G to pull more than, like, 50 watts worth of vCore is going to be an absolute, like, I don't think that's even really possible. Is it? Wait, no. 50? No, it'll be 50 amps at like 1.5 volts. So that'll be like 75 watts. Which is still like, you know, that's like what, 1/3-ish? So, not ideal. Really not ideal. I guess I could, well, at 1.5 volts it might pull 60. Always the option, right? Like, just crank up the voltage until it runs really, really hot. But... yeah. Anyway, like, this is a totally random video. So, yeah. At this point, it's just like, I'm not sure that I'll build a 2400G Probinator anytime soon. Because there's, like, equipment issues I need to deal with before that, but... so those take priority, because obviously test equipment costs way more than CPUs. But, well, way more than 2400Gs, so... that takes priority on the... purchasing list. But Yeah, and this does have liquid metal on it. I actually need to rerun this chip in this motherboard for iGPU benchmarking, or the other Gigabyte 2 dimmer I have. But I want to use this board. This board's like, this ITX is freaking great at memory overclocking. Which, to be fair, the other little board I have is also pretty good at that, but that one's VRM is like not that great, whereas this one's VRM is freaking awesome. So I'm kind of hoping... Well, I've done a bunch of mods on the other one, so it might be better now. Anyway, so yeah, I'm not sure if this will go public, if ever. But actually, this might go public after I already have the equipment situation sorted out, so... Anyway, that's it for the video. Thanks for watching. You know, this was probably horribly boring. Though I know there's some people who apparently watch my videos just because they like the sound of my voice, in which case, well, those guys are satisfied, aren't they? But yeah, so thanks for watching. Like, share, subscribe, leave any comments, questions, suggestions down in the comment section below. And if you'd like to support what I do here with actually hardcore overclocking, then I do have a Patreon where you can support me directly, or you can buy like AHOC shirts, stickers, posters, hoodies from Teespring, which you'll find a link to down in the description below as well. So yeah, and both of those help out with running the channel immensely. So yeah, thanks for watching, and goodbye.